for you. How to dress for school on a sunny versus a rainy day. Sounds a little silly, doesn't it? But go along with me for a minute here. If it's a sunny day out and you dress as if it's going to be raining, you're going to look a little strange, right? Your friends are going to think this guy or gal is a little offbeat. And so there's a consequence to your misplaying the cards on the sunny call here. Likewise, if it turns out to be a rainy day and you have dressed for a nice sunny day, at a minimum, you're going to be very uncomfortable, assuming you're outside. So we're going to look at this simple question: how do you make a decision if you should dress, assuming that the day will be sunny or rainy? Seems pretty simple, right? All right, we're going to bake into this problem, or this question, all the ingredients of making a good decision. Like, should I invest in a new car program? Okay, here's some of the ingredients. And the first thing here is the state of nature. And we're going to assume here that a day has two states of nature. Tomorrow it can be sunny or it can be rainy. So two states of nature. And we're going to assume that you have three options open to you. We'll call them actions. And those options are: wear a fair weather outfit, and I'll denote this by L. A2, wear an outfit with a raincoat, we'll denote this by M. So think about low, medium, and high. Third option is wear an outfit with raincoat, boots, rain hat, and umbrella. We'll call that high. Okay, so here's the decision setup. You've got two possible states of nature. You don't know for sure which one is going to come into play. And you have three options. Three actions you can take. When you walk out the door in the morning, you can dress L, M, or H. Okay? Pretty simple so far? All right. Let's go to the next concept. Remember we said there had to be consequences to a decision? There were no consequences. Dress L, M, H. Who cares? There's no consequences. So let's build into this little problem the consequences. We'll back up here. What did I do here? Here. And we'll call the consequences. Here we go. We'll do it through a loss table. So you could say, if the state of nature turns out to be theta 1, sunny, and I dress with L, I take the A1 action. Remember that was sunny dress, so to speak. Then there's no loss. I did the right thing. If, on the other hand, I dress M, using action A2, there's some loss. You're uncomfortable, you look a little strange with your colleagues, and so we'll say you lose 1 unit. Now, the units might be dollars in the investment of the car program. These would be millions of dollars. But in our little example, well, let's say it's dollars, just for specificity. And if it's really a sunny day out and I put all the rain gear on, then you really look strange to your colleagues, and you're extremely uncomfortable walking around during the day with all of these particular clothes on. So we'll say you lose $3 on that one. If it's rainy and you dress as if it's sunny, we'll say you lose 5 units. You're getting wet, you're getting cold, and you also look strange to your colleagues. 3 units here, 2 units here. Is this okay? Now, you can put in anything you want here. The critical thing is there's a loss table. There's a consequence to the actions that you take, conditioned on is the state of nature when you do it? You with me? Now, in spirit, you could have lots of states. This table could be very large, but it would be the same logical thing. It would be a listing of the possible states of nature, a listing of the actions that you can take, and then just filled out with how many dollars do you lose, or how many millions of dollars do you lose, or how many, sometimes we call them utils, U-T-I-L-E-S, which encompass loss of reputation, etc., etc. Is this okay? So that's the deal now. You've got the states of nature, you've got the actions, you've got the losses. Now, you don't go into this thing totally blind. In the case of introducing a new car into the marketplace, we don't go into that totally blind. We run little clinics, and we have people come in and look at the models and say, what do you think? We get partial information. Well, in this little example, you can check the weather forecast, right? So we get some information about what the state of nature is going to be at the next step. In our example, we'll use a weather forecaster. Now, weather forecasters aren't perfect. Neither is consumer research perfect. So we have this, in this case, we'll say the probability matrix that goes along with this weather forecaster. When it's a sunny day, the weather forecaster has called it right 60% of the time. They've called it a dubious day 25% of the time, and they've said it's going to rain 15% of the time. When the weather has turned into rain, it turns out the weather forecaster had called it sunny 20% of the time. They said it was dubious 30% of the time, and they called it correctly 50% of the time. Now, the numbers, the specific numbers are immaterial. You can put in whatever you want. If it's a great forecaster, the numbers will shift differently than what I have up here. If it's a lousy forecaster, it'll shift in the other direction. But the important thing here is we have some knowledge of the state of nature. And in this case, it's gleaned from our weather forecaster. Is this all right? So what have we got? We've got states of nature that tells us what the future is that we're looking at. We've got the actions that are open to us. We've got the consequences of those actions in a loss table. And we've got partial knowledge about the future, in this case through a weather forecaster. Not perfect. There's nothing perfect here. There's probabilities involved, but that's life. There's nothing perfect about looking at the future, generally.